Recall that the degrees of a measure of a circle is 360 all around, right? Today we're going to talk about the arcs that are formed, parts of the sides of the circle. Think of it as part of the outside of a pizza, the bread crust around it. So a minor arc, each minor arc of a circle is associated with and determined by a specific central angle. The degree measure of a minor arc is the same as the degree measure of its central angle. That is very, very important that you understand. They are equal. The central angle and the minor arc are equal. For example, if the measure of central angle PRQ is 30 degrees, then the degree measure of its minor arc PQ is equal to that, 30 degrees. Using symbols, this can be expressed as follows. If we use the angle symbol, if angle PRQ is a central angle and that letter M stands for measure, and the measure of angle PRQ is 30 degrees, then the measure of arc, represented with, remember that little curved line at the top of the two letters, then the measure of arc PQ is also equal to 30 degrees. So here we have two circles, and they represent, think of them as steering wheels. And the points on the circles represent the positions of a person's hands on the steering wheel. For each of these circles, use the given points to draw a central angle. And let's say that the hand position on the left is 10-2, and the hand position on the right is 11-1. And that just represents, let's pretend this was a clock. Your hands would be at 10 o'clock and 2 o'clock in the first circle, and at 11 o'clock and 1 o'clock in the right hand side circle. So I'm going to take a screenshot of this, and we're going to draw those central angles. All right. So we take our ruler. There's that. Oopsie. And done. Okay. So, what are the names of these central angles? So remember, we name central angles. We name all angles with 3 letters. The 2 letters on the circle and the vertex. So the first one, what do you think we would name the blue one? If you said angle AOB, that is correct. So you can go ahead and type that in. And based on that, I think you can figure out the red one. Very good. All right, without using a protractor. Now this might be a little bit, this is going to be fun to think through, okay? Determine the central angle measures without using a protractor. Remember, we use a protractor. It's a kind of a ruler for angles to determine their measurements. Without using anything, do you think that you'd be able to figure out the measures in degrees of these 2 angles? So you can go ahead and pause the video and kind of think through that for a moment. All right, so if you didn't quite get that, don't feel bad about it. This is a very, very not super easy question. So remember I said that let's look at the blue angle here, angle AOB. Remember that the hand position on the left was at 10 o'clock and 2 o'clock. And remember I said that, recall that the degree measure of a circle is 360 all around it. Well, if there are 12 hours in a day, we could take 360 degrees and divide it by 12 to get 30 degrees. And that means that each hour then has a measure of 30 degrees between every hour. So from 12 o'clock to 1 o'clock, it would be a 30-degree angle. So if you look at angle AOB, and we start at 10 o'clock and then we're going to go to 2 o'clock, how many hours between 10 and 2? Well, there's 4 hours. So we could, to find the measure of this angle, all we would have to do is multiply 30 times 4. And so our answer would be 120 degrees. And we would use the same method or thinking process to find that the measure of the red angle, CPD, is measures 60 degrees. Awesome. Now, how do these angles compare? So let's not just look at how we could find the measures without a protractor, but comparing them, what do you notice? Go ahead and pause the video and see if you can figure that out. If you look at those, go back to the picture if you need to. How do the measures of these angles compare? Well, if you notice that angle CPD is half of the measure of angle AOB, that is correct. Go ahead and type that in. Now here's a very interesting question. What do you think? Why do you think the hand position represented by the circle on the left is recommended and the hand position represented on the right is not recommended? So if you were driving, why would you imagine that placing your hands farther apart on the steering wheel is what is recommended versus closer together? And this could be, there's many answers you could think of. One thing that I could think of is, first of all, we have the airbags that have been installed in the steering wheels, and I could imagine that it would be safer for your hands to be farther apart so that the airbag can function appropriately. Another thing that came through my mind was that it's a little hard to turn the steering wheel perhaps with your hands closer together, and it might be easier when your hands are farther apart. So go ahead and type in your thoughts there. All right, last two for this one. So we have describe the measures of the minor arcs. So more descriptions, just think through. This is all about thinking logically and what you can think about here. So let's see, how can we describe the measures of these arcs? What do we notice? Well, we know a special word. Back in the day, we learned a special word called the perimeter. And right, so if we knew the perimeter of this circle, and we call perimeter of a circle, we call it a circumference of the circle. So if we knew the circumference of a circle, and we knew the distance between A and B, we could possibly find the fractional difference between the arc that we're looking at in comparison to the larger arc, or in comparison to the entire circle. So we could say that the measure, let's look at the first circle, the measure of arc AB is basically, so we said it was 120 degrees, right? So it's 120 degrees out of the entire circle, which is 360. And if we simplified 120 over 360, we would end up with 1/3. So basically, arc AB is 1/3 of the entire perimeter of the circle, or circumference. Using the same thinking process, we can say that the measure of arc CD, the length of it would be the same thing as if we look at the measure of angles CPD in comparison to the entire circle, which is 360. And we can find the length of the arc CD as well. So if we simplified 60 over 360, we would get 1/6 of the circumference or perimeter. And that would give me the length of the arc CD. Now I apologize, I think earlier I was explaining it as we were looking for the measure of arc AB, but we're actually finding the length of these arcs. All right. So just to go ahead and type your thoughts there, describe the measures of the minor arcs. We were comparing the lengths here. Also I just gave you some thoughts to see what you could jot down there. Think of this more of like a discussion. Last question here. Says plot and label point Z on each circle so that it does not lie between the endpoints of the minor arcs, and then determine the measures of the major arcs that have the same endpoints as the minor arcs. So we're going to go ahead and take a screenshot of this again. Actually, we've already taken a picture of this, so we're just going to go ahead and use the same one we have. So let's say that point Z is down here. That's not very pretty. So I'm going to go ahead and try that again. Okay, so we know that the measure of AOB is 120 degrees. Well, we know that the whole circle is 360. So to find the measure of the larger arc here, all we have to do is subtract it from the entire measure of the whole circle. So 360 minus 120 would give us that answer. And here we said this one was 60 degrees, and we would do the same thing to find the measure of the larger arc, 360 minus 60. And that would give us that answer. Okay, so go ahead and type your answers to upload your picture, and I'll see you in the next video.